All right. So a very good morning to all of you. Well, basically, good morning to all of you, those who have joined from India, those who have joined from other places across the world. Good afternoon, good evening, according to where you are from. But most importantly, thank you so much for taking your time out and joining us in today's webinar. Today's webinar topic is where we'll try to discuss the machine learning applications in FinTech. And to discuss this, we have, or rather, we are very glad and honored to have Mr. Sujit Vittam, who will be presenting on this topic. Once again, a very warm welcome, Sujit. Thank you so much for joining.
Thank you, Nitish. Thank you for the intro. Great to be here.
Right. So just like before I hand over the session to Sujit, I would like to give a brief intro about Sujit. Most of you have seen about his background in the communications that you have seen, but for the formality's sake and just to introduce him formally, Mr. Vittam is the managing partner of Forward Leap Capital, a venture capital firm with offices in San Francisco and Chicago. His firm extensively uses artificial intelligence and machine learning methods to make smarter investment decisions. He is an experienced entrepreneur, consultant, and finance professional with a huge expertise in AI and ML, statistics, and finance. Sujit has recently published a research paper on machine learning. He, as far as educational background is concerned, he has earned his Masters of Science degree from Stanford University and also has another Masters of Business Administration from University of Chicago Booth School of Business. Before I hand over the session to Sujit, I would like to give a little laydown on how we plan the webinar session, right? So first, Sujit would, of course, be presenting on his topic. And while he's presenting, in case anybody has any questions during the presentation or even after the presentation, we always want our sessions to be interactive. So please feel free to type in your questions in the chat window for the propriety sake, since we have a huge number of participants. So it will not be possible to allow everybody to speak. Otherwise, it will be difficult to manage. So you can type in your chat window, type in your questions or queries or anything that you want to discuss in the chat window. We'll take up your questions during the Q&A session, which would be after after Sujit's presentation, right? And if while we take a breather, we will also briefly give a little bit more introduction about our institute, Indian Institute of Quantitative Finance. So with that, I will hand over the session to Sujit. Sujit, just allow me a moment. I'll make you the presenter.
Sounds good. Thank you, Nitish.
So here you go. Sujit is the presenter. Here, the session is yours, Sujit. Thank you.
Thank you, Nitish. Thank you for the intro. I appreciate it. So how do so my screen is visible to everybody right now, or is that?
Yes, absolutely. We can see your screen, we can see your presentation, machine learning applications in FinTech. So we're all set to go. Thank you.
Thank you very much. So just to give you some additional background, I was teaching at IIQF many years back. I had a great time. Many of that was like about 5 to 10 years ago. So had great memories about that. Glad to be back.
Yes.
Talk about some of the
talk about some of the. Always a pleasure. Your lectures were always wonderful. So we also have very, very fond memories, as you know. So yeah.
Okay.
Glad
Fantastic. Fantastic. So machine learning, that is, I've been working on all sorts of machine learning topics for last 10, 15 years. Recently, I published a paper on deep learning, regularization methods in deep learning. So that topic I'm planning to cover a lot, and I think that would be that's making this topic about deep learning neural networks. That's making a huge amount of impact on everything that that's done, whether it is in finance, whether it is in technology, everything like insurance, you
Absolutely.
name it. Uh, the the deep learning models, which is like a part of the machine learning umbrella of topics, right? Of areas that's making a lot of impact. And
Correct.
hopefully, I can tell you some things that I published and working on recently. So let me start with the deep learning models and what are they. And these told me that the students come from all sorts of backgrounds, so I like to uh, present everything in a way that would be digestible and that would make sense to everybody, at least most of you guys. So the deep learning models, the inspiration for deep learning models come from neurons. They are also called nerve cells. They are the fundamental units of our brain and nervous system. They are responsible for receiving sensory input and also sending motor commands to muscles. So they take input values, process it, then send a signal to the muscles or everything else on how to do it. So this was the inspiration behind these deep learning models. Since they were developed like in the 70s and 80s. And you might think it's a minor point, but you'd be surprised even the computer scientists in 2022 when they present something in a top journal. I recently had a chance to read one of those articles. Though they keep on using this analogy, and they kind of try to relate this particular type of modeling to the biological uh, aspects of the neurons. So this is a common theme, and which is a powerful analogy in my opinion, because we are talking about artificial intelligence. We are trying to mimic how a human being acts and performs. So it's only natural to try to mimic the fundamental unit of the brain, which is the neuron cell. So just for those who are curious about it, this is the structure of a neuron cell. The deep learning models are going to be, as you'll see in the next slides, they're going to replicate what's happening in a neuron cells. So basically, there are the dendrites. I hope that's how it's pronounced. So these are like tentacles, like an octopus, sticking out. They receive messages from other neuron cells, and they are processed, and then there's at the other end of the neuron cell, which are called the terminal buttons. So they these are the input sensors. These are the output sensors, and signal from these terminal buttons are released outside and received by the next neuron. So signal come through here, get processed, get outputted here, and the next neuron here would be receiving the signal output from here, and so on and so forth. And let me go to the next slide. This is the biological neuron, and this is the deep learning neuron that we kind of model based on, right? So I'll tell you about how they are similar. So this is a one node or one node in a deep learning network, and it would be analogous to a neuron in the body, in the brain. What happens is there are a whole bunch of input values that are coming in, and there are weights W1, W2, W3, Wn, these are weights that needs to be estimated. These are like model parameters. So what happens is we take a linear summation of these input variables and the weights, and that's this summation sign is talking about. So summation x1 w1 plus x2 w2 up to xn wn. So this is the number that is calculated at this point, and they are then passed through something called activation function, and so activation function, or I'll talk more about it later on. So they receive the some value, and goes through the activation function, and some value is outputted, and that would be the output of this one neuron, one artificial neuron. Okay. And you got to imagine in the human brain there are like 50 to 200 billion neuron cells, nerve cells. So here this is just one node. In a typical deep learning network, there will be like millions of such nodes, probably billions. So it's not as huge amount as what's in the brain, but we are getting there as the computational resources and computing power increases. We are approaching that number of neurons that's in the brain, human brain. So that's the artificial neuron, which is the building block of a deep neural network. And next one, yep. So I told you about the activation function. So the input variables are these. The weights are W to Wn, which needs to be estimated. Just like any model parameters, right? In the regression, they got the betas. Any model would have parameters that needs to be estimated, and so then they're summed up like this and passed through an activation function, and then the output value. So this activation function, what is this? This is exactly what happens in a biological neuron cell also. So the values are received here, and some are amplified, some are made less strong. That's what exactly these weights are doing too. Then they summed up the combined value of that signal is reaches here, and depending on the activation function, it just releases to any one of this one. Same thing happens in the human body also. That's why these models have become so prevalent and very powerful in predicting, solving whole bunch of problems that we see today. So common activation function, this is the most common one. We use that in our paper too, and this one produces the best results. It's called a rectified linear unit, or ReLU, and it's just a simple one. So max of 0x. So the summed value of the input, the weighted sum of the input value comes through here. If it's a positive, then that's the value. If it's a negative, we assign the value 0. So it's in the nerve cell also similar thing happened, right? So if it's actually beyond some threshold value, then it makes an impact. If it's like less than that threshold value, then there is no impact. So that's the ReLU activation, most common and probably most effective also. And the other one is a sigmoid activation function. This is 1/1 plus e to the minus x. So it's a little more wider spectrum of values, including so it is like this is less common though, but still some people use it. Another one is that arctan, not arctan, like the tanh function, which this is like a rarely used. So I never seen people using this one at all. So some of the common activation functions used in an artificial neuron. All right, this is a this is a schematic. This is a the architecture of a deep learning neural network. I told you, like, it started in the 80s and 70s. So this was, at that time, it was called the artificial neural network, ANN, and they are a whole lot simpler than what we have today. ANN, first of all, has, okay, let me start with the ANN here from the 80s. So there are the whole bunch of input. This is called the input layer. This is called the hidden layer. This is the output layer. And as you can see, all the nodes are connected, and they are called, if that's the case, this is called a fully connected neural network. Okay, and according to each link's weight, this like is written here, there will be like a W1, W2 for each of these, that edge or like a connection link. There will be a W associated with it, a weight value, and all those the weight value has to be estimated also. So as you can see, there's a whole bunch of parameters there, huge amount, even for a simple model, simple artificial neural network as like this. And in the I would say since 2000, or definitely after 2010, people start to pay attention to something called the deep learning neural network, which is a kind of a juiced up version of the old ANN. There's fundamentally the same thing, but it's more like a convention. If there are like at least like 3 hidden layers, people call it a deep learning network as opposed to the artificial neural network. So it's a similar thing, but there are going to be some extra hidden layers. Here I see 3 of them. Even just 3 makes it like such a complex model. But in the real world, the models that are used by Google and Facebook and LinkedIn, they would have at least like 100 hidden layers. But everything else is kind of the same idea here: input layer, multiple hidden layers, and output layer. And the picture here is basically saying that, first of all, the deep learning models are extremely effective in image recognition and image identifying, image classification, and so on, which are which are kind of important problems that are dealt with in today's world. But coming back to this model here, so let's say there's an image of George Washington here, and each of the layers, hidden layers, kind of hierarchically pick up the features. So at this stage, it will be just the pixel data of this image. So every image would have like X amount of pixels, right? For example, one dot here. Okay, that's like a if it's a color image, we have like the RGB values, 3 values for each pixel. But if it's a black and white image, it's like 1 image for the intensity of that pixel. So at this stage, it's just that data. And after you go through the first layer, it identifies these lower features like edges. At this level, it will be like a combination of edges. So it's like much more much more complex identification, and it progressively become more and more complex features are identified. Here at this stage, you can see the nodes are actually figuring out the shape of the nose, eyes, everything. And at this stage, it's a output layer. So here the actual image is identified. If it's a George, there's a node for here George, and that would be activated though. So that means, okay, out of the 4 possibilities here, It could have been any 4 different people, but since this was activated, it was correctly identified as George Washington. So that's like the typical deep deep learning neural network architecture. Very well. So this is a vast topic, and it would be beyond the scope of this talk to go into the details of each and everything. But just some of the word terminologies that you will see when you're building deep learning models is like a back propagation. So that's like the algorithm that was developed long time back. A very interesting algorithm that made it all possible, really. So that's the algorithm that's used to estimate those weights, and those weights are the parameters of the model. So depending on the what value, the whole model fitting is about calculating those weights. There's another terminology that you'll see is a cross entropy. So just like for any model, there will be a loss function. So if any machine learning models or any model, generally there will be a loss function that we need to minimize. The whole idea about model fitting is there will be whole bunch of parameters that need to be estimated, and we calculate the set of values for those parameters that would minimize the loss function. So deep learning, people use this cross entropy loss function, especially for classification problems. So if it's like for example, to give a concrete example, in classification problems, just like George Washington image, right? There are like 4 categories possible, and if there's a one category that was misidentified, then we can calculate a cross entropy, estimate the value of it, and that's a loss function that's typically used in deep learning models. And another thing, I talked about all this in my paper also. There's something called a vanishing exploding gradient problem. That was one of the reasons why in the 80s and 90s people lost interest in artificial neural networks. But recently there were lots of researchers have developed methods to fix that problem. But the problem basically is like when you use this back propagation algorithm, these weights might get extremely small, or it could go the other way around. If it's an exploding gradient problem, then the weight might get like 10 to 50 or something. So then that kind of mess up all the calculations. That was a big issue, a long time back. But recently, for example, in our paper, we used one of the methods proposed by some other authors to deal with it. Basically, if you use intelligent initial values for the weight, and then that we can solve that problem. So that's another terminology that we'd use. And learning rate, it's not specific to deep learning, but it's a parameter that is used to calibrate the step size at each iteration while moving toward a minimum of loss function to calculate the waste estimate. That's a lot of words. Basically, it, how I would say is, in all these modeling process, there be a loss function that has to be minimized. So automatically that means it's an optimization problem, and it's an iteratively optimization problem. So these are so complex, and there's no easy way to minimize it. There'll be like iteratively minimizing the loss function. There'll be like 200 iterations to converge to a minimum value, for example. So my point is, the step size function is a parameter that we can calibrate to to uh, to make sure that those iterations don't go too fast or too slow. So sometimes you don't want to converge too fast. Then that optimal value may not be the global optimal, but you don't want to converge too slow either. So the learning rate is an important parameter that we need to keep in mind. Next thing I want to talk about is the regularization methods, because this is the paper I wrote about, and it's a very exciting area of machine learning research. Many famous machine learning researchers today, they became famous because of their regularization research. Actually, I can think of at least a few people who wrote groundbreaking papers on regularization methods. So this is the simple idea behind it. So here I show a bunch of graphs. Suppose the blue dots are the data points, the data that we have, and we have the dotted line is the model that we are trying to fit. So as you can see in the left, this diagram, it's a too simple model, right? That's why what is called underfitted model. Here it's just about that dotted line is capturing the overall story that is being said by the dotted points. So we call it a good fit, robust fit. I'll come back to this bias variance thing. And here is a case of overfitted models. So it's like it fits the data perfectly, but the problem is when you try to, the whole point of model building is to predict the future, right? uh, and when you try to predict another point here, for example, you know uh, since this is so tailor-made, custom-made for the data that we have, when you try to predict something that's not there, which is the whole point of building the model, this thing fails terribly. So that's what is overfitting is called. In other words, it's a very important concept. uh, you know, for this, here it says high model complexity, there is a large number of model parameters, results in overfitting. And in deep learning, it's an extremely important problem. I mean, common problem, because the number of weights, the number of which are the parameters here, the number of parameters are in the millions, and so it's very, very easy to overfit the model. And there's this theory, mathematical theory behind what's happening here. You can think of there's an optimal model complexity. So when we try to uh, build a very, very complex model, what happens is the variance, the bias decreases, basically meaning it fits the data perfectly. But there's another concept called variance, but the variance increases when the model complexity goes up. So there's that optimal complexity level, which should which should uh, um, which should be uh, result in the minimum total error. That will be the variance plus bias score. These are all mathematical stuff. We can prove it actually. So, just to touch upon it, what is the variance here? Meaning, I can explain it like two words, two sentences. So, suppose we have a whole bunch of data here, and we build models using that data. And you might think every time you're going to end up with the exact same model, but definitely not. You might, depending on how the initial values are and how you frame everything, it might be the same data X, but you might end up with three different models. And here the figure says that suppose for the same data point, the three models predict three different output values. That means there's a high variance error. And here is the other way around. The input values are different, and the model is supposed to produce 3 different output, because the input is different, so the output would be different. But if your model has high bias error, that means the output is going to be the same. So similar to here, doesn't matter what the input value is, output is same. So that's what we call bias error. So high variance results in overfitting. Here, as you can see, it's the same date input value. The model is supposed to produce a same output value, but produce a 3 different output value. That means it's a high variance error. Here, it's underfitting. It doesn't matter what the input value is, the model is always going to give you the same output value. So that's a bias error, high bias error. So overfitting, coming back to my point, overfitting is a common problem in deep learning because of the huge number of parameters. I have never seen any other models like with that many number of parameters to estimate. So overfitting model, overfitting is a very common problem in deep learning models, and that's where this regularization method comes in. Regularization is a solution for overfitting problem. Regularization basically put a penalty on the number of the value of the weight or the number of the weight. There's a theory I can go on and on, but suppose we have like a million weight values to estimate in the deep learning model, and so regularization means that we want to limit put a uh, put a limit on the number of variables and the value of the variables, which are like from a theoretical standpoint, they are like similar concepts really. So we say that we got a million W values. We are gonna put a constraint on that value, saying that the sum of all those weight estimates has to be less than 1,000. So that means like we are regularizing that parameter estimates. We are making sure that the estimates don't blow up and just become too tailor-made for the model in hand. So that's the whole idea behind regularization. And I think I talk more about it on the next slide. Okay, so yeah, so this is the paper that Nidish was talking about. I wrote like 3 papers actually recently. Regularized deep learning with non-convex penalties, and another one that got published in Applied Mathematics, on 2 recent non-convex penalties in regularization in machine learning. And we just 2 weeks ago we submit this one for publication, the 3rd paper. So here in the papers, what we did was we proposed 3 different type of regularization methods. One is the Laplace method that we propose. So as you can see, this is the regularization function. Whenever the value W is to be estimated, we calculate 1 minus epsilon raised to the W value, and we sum it up. So that's the Laplace regularization that we proposed. And this okay. How, when we are using the regularization method, this is what happens. Usually when we are trying to do is like minimize the loss function that's denoted by this L here. But when we are applying regularization methods, we add like one additional term. lambda times the penalty function, which is this p-value here. So we are trying to minimize, find that value of w, the weight, that would minimize the whole both sum of these two functions, So that's the way the regularization methods are applied when calculating the weight estimates. There's lots of math behind it, but it's I encourage you to go through that paper that I wrote, and there's a huge amount of math and theory behind all of it. Second regularization method that we propose is the arctan. So it's instead of this 1 minus epsilon raised to w, it is like an arctan of gamma times wj. And there's a gamma, the subscript gamma, epsilon, they are like a tuning parameters. They are like an additional parameter that we need to estimate in addition to the weights. This one Gaussian is the latest paper that we wrote, and I know that's another variation of this function, 1 minus e to the minus. As some of you might remember, this is like the Gauss normal distribution term, right? E to the minus k w square. So these are the Gaussian parameterization. And I think I put a table. Yeah, this is a table from the paper. Okay, let me pull it down here. So, okay, so these are our methods were tested out in a whole bunch of different data sets. They're called toy data sets. Basically, these are famous data sets that are used for like last 25, 50 years to test various theories and find out how they match up with the other ones. As you can see, we tried it without any regularization. This is the error rate. So lower the error is better. So that means that it's two things I would like to point out. So these first three columns I use deep learning neural networks. So without the regularization, the error rate was like a 1.87%. So that deep learning network was able to predict with like a more than 98% accuracy, which is like unbelievable. So that goes to tell the power of all these deep learning methods. And just to, I don't want to get into the big detail about it. You can Google it yourself. The MNIST is a data set of images of digits from 0 to 9. So it has been there forever and ever. So you have a image of a image of a digit. It could be like 5 or 6, handwritten image, not like a digitally written, but some guy wrote the digit 6 and there's a photo of that. And and the model was used to predict, oh, okay, this 5 is actually 5. The guy who wrote 7, it's actually 7. So this is important when for the postal service, like when they are scanning a postal code, right? So they want to find out that 6-digit number or 5-digit number. Okay, so they say, okay, they can use this model to say, okay, that 7, it's 58198, that sort of thing. And this model without any regularization was able to produce 1.87 error rate, which is like it's a percentages, so more than 98% accuracy. And we tried out the same model on a whole bunch of other regularization method. These are all very famous regularization method. Lasso is L1. Another one is a ridge. My professors, at Stanford actually developed all these methods, but they are very famous ones. And these are the 4 ones that we proposed. As you can see, they're all better than the 1.87. And the Gaussian one that we proposed was able to produce the lowest of them all. So as you can see, the error rate came down from 1.87 to 1.19. So this is a Gaussian method that we proposed, produced prediction accuracies that are much better than the traditional lasso or ridge. These are other data sets that we tried it upon. FMNized is another one similar. It's like not digits, but items of clothing. It could be like shirt or pants. So the model has to figure out if, based on the photo of that item of clothing, whether what it is. So if it's like a tie or is it like a pants, whatever. So the regularization that we proposed was able to produce. It came out to be the best of everything that we tried out, and it produced like a 9.72 error rate, which is unbelievable. This is better than lasso ridge regularization. RCV is another toy data set. It's the Reuters newsfeed data, so text data. So there's a whole bunch of newsfeed data. Basically, it will be like a 3-line text data about some news happening in some areas of the world or some industry. It could be like finance news. It could be about like some other sports news. So based on that input data, we actually uh, 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 classify it. Classify which category that news is. That's a RCV data set. And CIFAR, these are like much more complex data set. ImageNet, SVHN, these are so CIFAR is actually these are all very famous data sets. So these are like images, photos of a whole bunch of stuff, and they are downloaded from Facebook, I believe, one of the social media accounts. And there are 10 categories of it, and could be cat, dog, or bicycle. So it's a very very messy data. It's like literally some guy took a picture of a cat, right? So that's why the error rates are much higher compared to the MNIST data. So CIFAR data, these are all very famous data. And we have to use a different type of a neural network called the convoluted neural network, which are much more effective when they are doing image recognition algorithm models. And CIFAR 100, and the Gaussian regularization method that we proposed came out to be the best in these two one, which are absolutely amazing, really, because people have been working on this kind of problems for decades, and to be able to come up with a method that has produced a accuracy level that is better than everything other people have figured out, discussed all these years. That's amazing, actually. And SVHN is a street sign data. So in the US, I don't know, I haven't seen in the India, but in the US they have the street sign, and some guy took a picture of that street sign, and only the numbers are identified. So it will be like some number is there, but it will be much more messier data than MNIST, so that's why the error rates are higher. And that also our methods kind of perform better than everything else. And ImageNet is like it's the most popular toy data set out there. They are like different data set that is much more messy, that is much much more difficult to predict because it's that much more unstructured. And but our method was able to accurately calculate, comparatively do better than everything else. So that's the paper that I wrote recently. All right, coming to the applications of my machine learning in finance, there is quite a few of them. Many times what happens is these are like very proprietary and trade secrets. So if some there is a fantastic way to get an advantage, they're not gonna talk about it to a million other people, right? So they would keep it extremely secretive. So it's hard to kind of get information about some of this stuff, but there is a huge amount of discussion about applying machine learning methods in commodity trading using satellite imagery. So one thing I forgot to mention was like these deep learning models are very effective in the kind of, okay, let me just step back one more. Computers have always been better performing than human beings in some aspects, such as multiplication. Now you can ask a computer to do a million multiplication. Human beings would never be able to do that well, that fast. So there are some areas computers have been always really good, but some other areas computers were like falling behind. There are things that human beings can do better, like a visual identification, or audio identification, or sensory identifications in general, uh, uh, like a these are two important categories, but these are things that human beings are able to do much better, because if we can look at a cat, and human beings can instantly say, oh, that's a cat, but a computer, that would be a big challenge. But my point is that this deep learning models and AI, which are that's why they are making a big impact in this AI field. They are able to that uh, achieve accuracies as good as human beings, especially when computers are getting better and better. For example, using these deep learning models, we can actually do better than human beings can. So for example, uh, you know, uh, eventually they are getting there, approaching that level. But within the next 5-10 years, maybe sooner, these deep learning models will be do a better job than human beings ever can, like in everything. If that's where these are AI uh, you know uh, things that we see in the sci-fi movies come into play, like human AI robots taking over the world, that sort of thing. And my point is commodity trading, that's an area that extensively use AI/ML models. And there is a huge amount of literature written recently, and lots of articles about using satellite imagery um, to predict what's going to happen, to get an advantage, really. And imagery, that images do beautifully with deep learning models. So you can get satellite imagery from some company, and they can keep track of, for example, how much rice was produced, and how many lorries were moving around, and how many container ships of oil were are going from point A to point B. These are like image data, and these have small advantages. It's like when you're doing trading, even the smallest advantage you can get can result in a huge return, right? So people are willing to go take great effort do whole sorts of things to get an advantage. And there's a satellite imagery for commodity trading. That's a big application of deep learning models and AI, machine learning models. Another one is the credit risk management. The people have always used data science models for that, but now with the much more sophisticated, advanced deep learning models, um, every big bank, they are going big time on using machine learning models to predict credit risk. For example, a bank want to issue a credit card, right? So we can use that data and throw it into a deep learning model, and with high level of accuracy, beyond unbelievable level of accuracy, predict what's the credit risk. So people are going big time on that. And I read that Citibank recently, they completely going big time on machine learning models to develop uh, high quality credit decisions. They have been in the news lately about that. And there's another Morgan Stanley or a McKinsey report that say, like, the banks, they're planning to they're expect to add about $1 trillion in added value by using machine learning models. So all these banks, uh, they can take advantage of all these deep learning, machine learning models, and to do everything that they do much better. Like another big area for the bank is fraud detection. I have worked on a project regarding that one time. So if it's like a based on how the pattern of behavior of a customer, you can say if this guy is there's something fishy going on. Anomaly detection and fraud detection. That's a traditional machine learning problem. They used to, like, in the textbooks in the old times, there'll be like the spam detection, email spam detection models. That's a traditional text-based machine learning model. Same thing you can use for the fraud detection. You can based on everything, all the data, build a deep learning model, and that can predict if it's a legitimate transaction or a fraudulent transaction. So that's another application of deep learning models. And another one is sentiment analysis. I have used that, worked on that one a long time back. So just like talked about the Reuters newsfeed data, text data. That's another type of data that deep learning models can do very well. So the Twitter, for example, we can access that a billion data points, text data. I believe they give it out for free, or maybe some nominal charges. So if you can use that to take advantage of that data, to uh, invest better. And we're talking about billion-dollar investments that people make in Wall Street. And for example, uh, it could be, for example, like for example, if how many people are talking about a particular industry or particular type of product, or like if it's like buying a car, or going on a vacation. All this kind of data you can collect from Twitter and throw it into a deep learning model. Then that can predict, if there's a positive or neutral or a negative impact on a particular type of business in the next 3 months or next 2 months. These are extremely valuable information that these algorithmic traders and hedge fund managers can use to get that small advantage, and do do very well in their investment. So these are some of the applications, and there are a whole bunch of other ones too. But these are some of the interesting ones that I felt like a machine learning, deep learning model can do very well. Yep, that's end of the presentation. This. This. Ah, all right. Can you hear me?
Yeah, hi all. Hi all. Hope I'm audible now. Sorry, there was like maybe a small problem somewhere. Uh, Apologies for that. Thank you so much, Sujit, for the wonderful, insightful session. And before we go into the Q&A, right?
Yep.
So we'll allow you a breather of like maybe few minutes.
Okay.
And meantime, I will talk a little bit about our institute before we go into the Q&A session. So
Sounds good.
allow us like maybe few minutes, 4 or 5 minutes, and then we'll go into the Q&A. I'll moderate the questions for you, and then I'll request you to answer them one by one. So all participants, be with us for the answers to the questions that you have put up. And in the meantime, just to give Sujit a breather also, and like just to introduce ourselves a little bit more, I will share a little bit about our institute. So hope you're all able to see my screen. Right. So as I said, just to give Sujit a breather, and also to just like let you all know about the work that we have been doing uh, for more than a decade now to promote this field of quantitative finance, financial engineering, and risk management and related areas in India. So as you all know, I represent the Indian Institute of Quantitative Finance, India's oldest and principally still the only institute which dedicates itself to quant finance, financial engineering, risk management, education, and allied fields, right? And as you all, I mean, we are as an institute, we are dedicated to education, training, and consulting in the field of quantitative finance and financial engineering, risk management, algorithmic trading, and we also apply a lot of AI and ML based models in our courses as well. We are also just too happy to announce that we are coming up with specialized courses in machine learning and finance shortly. So we would be going into that area, specialized courses and that as well. Though we use machine learning in all our courses currently as well, but we would have dedicated courses in machine learning going forward very soon. And we are an education institute founded by pioneers in India and top experts from the field of financial risk management, financial engineering, investment banking. And we are focused on education and promoting education and training in the field of financial engineering, quantitative finance, risk management, investment banking, algorithmic trading, evaluations of derivative products, artificial intelligence and machine learning, and as I said, and several other areas of modern finance for more than a decade. So we have been there. Currently, we have very deep certificate programs in the following areas. So principally, we have 5 main certificate programs that we offer to as like open house programs. The first program is like the oldest program that we have, the certificate program in quantitative finance and risk management, a 6 months program where we comprehensively cover and we deep dive into both theory and practical modeling for derivative valuation and risk management. We have a very deep financial engineering course of 7 months on the weekends again, a comprehensive course where we deeply dive into both theory and practical modeling for derivative valuations and risk management. Then we have algorithmic trading courses. The first one is a 6 months course. We teach all aspects of algorithmic trading using technical analysis, machine learning, and quantitative models. We have a smaller algorithmic trading course as well for somebody who wants to concentrate on learning algorithmic trading only using technical analysis. When we do have a small course on Python programming for finance, for people who are starting out in this field, Python is like the basic skill that is required currently, because you see that's like that's like a platform or a language that is used in our area whether you talk about quant finance or financial engineering, risk management, algorithmic trading. Of course, you can use other languages as well, but Python is one of the most used languages, and we have developed or built a platform in Python for all the courses. And so if somebody wants to start, they can start small by first learning the basics of Python, and then they can go into our courses. So if anybody has an interest in moving into this field, or if you're already into this field, you want to go deeper and learn this deeper aspects of all these areas of advanced analytics in finance and machine learning, then you can consider these courses. We are also a partner of one of the international universities, University of Stirling, particularly for their UAE Ras Al Khaimah campus. So this is like a campus which offers international degrees at like a much lesser price compared to the same degree offered in their UK campus. So particularly it's a space for people in Asia, if they want to go for like an international UK degree in areas like where they have broadly 3 master degree programs, MSc Finance, MSc Big Data, and MSc FinTech, that is Financial Technology. These are all 1-year programs. Good thing is if you can do these programs with your job, because these are weekend courses where you get a master degree, but by attending weekend lectures. And on that also, the lectures can be attended both from India as well. These are online lectures are also available. You can be in the campus and you can take their courses there, or you can be here in India and like take it online. Only compulsory thing is they'll have to visit the campus 2 times in January and April if somebody is joining the September cohort, and in January and April to take their exams. So each will be about 4 days of stay, right? And these are like they provide extremely good internship opportunities both in India and UAE. They also give you placement opportunities both in India and UAE. So if somebody wants to do master's degree program at a reasonable price, a good university with a wonderful ranking worldwide, so if somebody wants to go for those degrees, they can. I mean, for people applying through us, there is some priority given for the admission process. So in any case wants to consider this, they can actually get in touch with us directly, and then we can connect you to the university and you can take your admission through us. Now, in the last more than a decade of us been conducting this advanced courses, we have been fortunate to have participants from various spheres of the industry, and then some of them have been, many of them have utilized these courses for their further enhancement of their career. Some of them have moved into quant finance and risk management and algorithmic trading by basis of these courses. So I mean, we do have some of the students and participants who have shared their wonderful thoughts on how they found the courses useful. So you can go to our website and see our testimonial page for them. And some of the example, I mean, not to showcase anything, but just to show that, like, again, these are actually courses which people from the industry have found useful. So if you want to go in deep into any of these areas, then definitely we would be glad to discuss about the courses as well, if anybody is interested. But I mean, anything related to the course, we will not take up during the session. So if somebody wants to discuss about the course, they can stay back after the Q&A session to discuss specifically regarding the course, or they can get in touch with us directly to discuss of the course. We'll not go more in regarding the courses. And the target companies of our the courses are like, of course, all these kinds of advanced financial institutions, hedge funds, investment banks, international banks, commercial banks, stock exchanges, consulting firms, all the leading IT companies and all that, and specifically for profiles related to quantitative research and analysis, development of quantitative and analytical software, building valuation models, model validation teams, portfolio management, portfolio analytics, and of course all areas of risk management like market risk, credit risk, operational risk, liquidity risk, derivative structuring, quant trading, HFT, high frequency trading, other areas of algorithmic trading and derivative trading. So if people are interested in this field, and of course, for the last, as I said, of more than a decade of a wonderful journey, have been fortunate to work with different leading financial and other institutes, as like their training, conducted trainings, provided placements to our students, to a lot of the organizations. So we had a wonderful relationship with the industry as well. I mean, have conducted courses in leading educational institutes as well, IIT Bombay, BITS, Pilani, NITI, to name a few. So these are just like a small list. So with that, I would like to end, and like we'll start with the Q&A session. And so before going into that, this is like our contact. So you can go to our website, iiqf.org. You can call us, you can email us, and info@iiqf.org. Of course, you have been receiving in our communications, so you already have our contact details in case you wish to go into that. Right. So thanks. So now we will go into the Q&A. Sujit, I'll make you the presenter again.
Okay.
Just give me a moment. Right. So we'll take up the questions one by one, the questions that we have till now. Just 1 moment. I'm just collating the questions. Right. So the first question was from Rajesh, and Rajesh has asked this question. He says that he's a trader, and he is not sure if machine learning is really worth it. He wants us to dispel the notion. He says that kindly dispel the notion. Seen Y2K, WMD, JINI, SOA, CDOA, VAR, all blown out of proportion to their actual utility. So he wants us to give the actual perspective of ML. And before
Okay.
going into that, I would also like to add, so to Sujit, to your presentation. So it's essentially when Sujit was discussing his application areas, I mean, as he rightly pointed out, ML is definitely like, area where, like, I mean, credit risk is like a huge area where ML is applied, and not only international, I mean, all the leading banks, but again, you'll see that there are like a lot of independent fintech companies also which have come up, right? So, and they have this specialized ML based models to analyze credit, and then like they lend based on their ML based credit models and not the traditional credit models. So that's again another huge area where machine learning is used in finance. Right. So yeah, coming back to the question, Sujit. So he wants us to dispel his doubt regarding ML and how. I mean, so yeah, please, if you can guide him a little bit. I mean, how ML can be used in the trading, and is it like too overrated, or I mean, people can actually build good models, machine learning based models to do very efficient trading.
Well, I know that for a fact that the high-end Wall Street firms are going big time on it because many of my classmates who who studied all these things, they are getting like $500,000 salaries and so on. But it's more like the very high end, highest level people who are the hedge funds trading like a $5 billion a day. That sort of good people, right? They are using it a lot. I'm pretty sure about that. But there are some other aspects also, like certain areas, like a deep learning model, for example, it's like a black box, right? And in a certain areas, you cannot apply it. So the person who raised it has some point there. For example, in the US, if somebody applied for a credit card and get rejected, there are state laws that says, okay, you got to explain why, what are the reasons why. You cannot say the deep learning model said, he reject this guy, so
Right.
in so certain areas, you're right, but this is like a big freight train coming at 100 miles an hour, right? It's like it's unstoppable. You cannot stop the power of this model and all. So it's like it's gonna happen one way or other. And depending on the industry, some are, especially the traditional banks, they are little, they're not, they are always risk averse, right? They don't want to jump into something right away. They are always a little bit lagging behind the other fellows. So it depends on the institution also, how much they are willing to bet on machine learning and all. But just like I said, these models, I'm just saying it objectively, and they are so powerful and so effective. May not happen tomorrow, may not happen 6 months from now, but it's sure gonna happen, like next few years, that's for sure.
Absolutely. Absolutely. So yeah, I mean, it is up to the modeler. Uh, Honestly speaking, a lot of things can be used in trading and are used, as Sujit rightly said, that a lot of them are being used into the trading. So there are people who have been successfully using it, but it's all on the modeler. So essentially, it's how good you use the model to predict things.
Absolutely right. Absolutely right. There's a, if you know the stuff really well, if you have some great insight, and if you can come up with some original ideas, just like I talked about satellite imagery stuff, so it's all up to the modeler. I totally agree with you.
Correct, correct, correct. Right. So again, a follow-up question on that Ranjan has. So how quantitative finance can be used in the share market? So what he means by like is like the market, equity market, or like all other asset classes.
Yeah.
So would you like to answer that a little bit?
Yeah, I mean, it's like okay. So there are lots of papers written about it, lot of articles, a lot of discussion about that particular thing. Predicting the stock, that would be asking too much, maybe. But if it's like some specific areas, subset of that, right? Like commodity trading, that's like a subset of the whole trading universe, right? So there are, you can find out like niche markets, like there is another um, another usage of this machine learning models, like predict policies or like political changes. So if you have one guy wins, obviously the stocks is gonna go up. That's more reasonable to be than if you're just putting the stock historical data and asking it to predict the next 5 days of data. That might be a little asking too much. But if we can, for example, we can suppose you want to invest in the Mercedes or BMW, and you can use a Twitter data to kind of get an edge on it, right? You can say, okay, lots of people are talking about this particular model that's gonna release in next 3 months. That's the type of information or trade intelligence. That's what they call it, I suppose. They can use to get an advantage. I don't particularly buy the idea that you can use the stock data to predict the tomorrow's data. That possible, but that might be a little bit of a stretch, right?
Yeah, just to add to that, again, I mean, the answer to that question also lies in the fact that when we talk about quantitative finance, then quantitative finance is not always about machine learning, right? So machine learning is like maybe one part of it. So I mean, though the topic of discussion today is machine learning, but to answer your question, right, Ranjan, how quantitative finance can be used in the share market, or like again, I mean, in the market in general, right? So quantitative finance as a field, by definition, quantitative finance, or alternatively, it is known as financial engineering, or as some people call it mathematical finance, computational finance. So essentially, this is like a field which uses mathematical models to value derivative instruments. So derivative instruments are always valued using mathematical models, right? And when you value something, and when you are able to value something well, that can always be used for trading, right? It's like you do with the fundamental data. So you value a company well, so you can buy or sell. I mean, if it is like an overvalued thing, you buy. I mean, you sell. If it's like an undervalued thing, you buy. Similarly, for derivatives, I mean, if you talk about a simple application, so quant is used heavily for trading. I mean, it's not, as I said, it's not only about machine learning, but quantitative finance is all about trading. And again, there are a lot of support functions, but it's actually a part of the quant trading desks, right? So they value the instruments, and then they devise trading strategies out of it. So quant finance is essentially all about trading. There are a lot of supporting roles, as I said. There are people who are building the models, who are validating the models, who are managing risk. But at the end of the day, I mean, this is all about trading, whether it's like an exchange trade or it's like an OTC trade. So whenever you are doing a derivative trade, and for yours, a lot of people don't know the derivative market is actually a bigger market than the normal equity or the normal fixed income market that you see. It's many times bigger, right?
Yeah.
So
Yeah.
quant finance is like a huge area which is applied to the market. And if you want to discuss this in detail, I mean, you can contact me directly, Ranjan, and I'll be happy to have a talk at length about this. I mean, spent more than a couple of decades in this industry in quant and related areas. So I'll be happy to share all my insights for the sake of like this session, and we'll go to the other questions. But yeah, that is, quant finance is all about, I mean, trading in the market and like valuing and trading, right? So.
And especially when I was teaching about volatility forecasting, that sort of thing. That would be like perfect for modeling. But
Absolutely.
so if it's like what's going to be the price of ICICI tomorrow, I mean that might be a little bit hard. But if we can predict, there are there are a whole bunch of things you can do very effectively with math and statistics and models.
Yeah. Yeah, absolutely. Particularly on the derivative side. In fact, actually, like people use quantitative models even for the fundamental as well. But again, not going into that now. But in general, it's everything about derivative modeling is like, I mean, and valuations is like quantitative modeling for this. So anyway, going to the next question, which is from Hari Krishnan. And Hari Krishnan, if you are there, I'm not sure about the question. So he has mentioned few terms from the topics of discussion: dendrons, axons, nerve ending, synapse, and hyperbolic FN.
Yeah.
So I'm not sure what was the question, but again, he has only mentioned these terms. I mean, I don't know. I mean, if you're there, Hari Krishnan, I mean, do you want us to elaborate a little bit on these terms, or like what was the question actually? If you're there, if you can actually just like add to your chat. I'm not sure whether he's still there or not, but I'm not getting any follow-up questions. Right.
Yeah, I mean, that's just like a biological,
Correct.
very
Maybe
interesting.
you can. Yeah. Please. I mean, if you can, like, maybe in a minute, just summarize
Yeah,
all this stuff.
absolutely. I mean, everybody should. There's a YouTube video about. I should have. You can Google it right now. Actually, YouTube video about microscopically how the neurons work, then you can see actually, these kind of signals going on through these dendrites, and also, it's very interesting. And people say, this particular cell is completely different from anything else in the body. So it's kind of almost like a little bit of mysterious in the sense, how they do these things. And but they are using this synaptic space. That's what they're talking about. That's the region where the input and output kind of connect. So that would be like I don't know if you can see my cursor. It will be this synaptic region is like that.
Right.
So, but these are all biological stuff. But interestingly enough, the computer scientist people still talk about when they write a paper about deep learning. There will be one session about the biological inspiration behind it. So, for
Correct.
example, there's another paper that was a very highly regarded paper that was recently published. I mean, 5 years ago published, and they were talking about a way to improve the accuracies, and one way they proposed was kind of knock off randomly some of those nodes in the model.
Right.
They say that, in human biologically, in our brain too, occasionally, randomly, some of the nodes are not functioning. And surprisingly enough, when they did that in the deep learning model, the accuracies went up like 20%. So it's like it's like they keep people, the computer scientists, researchers keep on using that biological uh, story even today when they're coming up with the new stuff. So
Correct. 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 Thanks so much for that. Actually, I mean, the brief recollection on those concepts. So next
yeah.
question is from Manikandan, and he says ReLU looks like a option payoff diagram of a long call option. Is this
Yeah.
used in ML application for portfolio management or optimization? Also, here's a follow-up question. When is sigmoid used as opposed to ReLU? Are there situations where one is preferred over the other?
Good question. You're right. Absolutely right. This looks like the option chart that I also, yeah, I mean, this diagram, the ReLU diagram, shows up in all sorts of situations. So it's like, it's just basically saying that if the signal strength is lower than a threshold, we're going to put a 0 value. If it's higher than that, it will be that value. But to come to your other second question about which method are preferred or not, and there's no unique answer. For example, in the paper that I wrote, what I did was we tried out all three of them and find out which is producing the best result. And in our case it was the ReLU, so we said okay, so we're gonna use ReLU. So it's all empirically calculated. So that's what I've seen other people do it also. Build models with each one of them. Try it with the ReLU, find out what's the prediction accuracy. Try it with the sigmoid. Find out what's the accuracy. Third one also there. These are the most common ones. There are a whole bunch of other ones too. There's one called I think it's called leaky ReLU or something. So instead of this straight line here at the bottom, it is like kind of going down a little bit. So the only way, there is no universal answer to your question about which one is better in which scenarios. It's all about let the data tell you which one is good for this particular data set. So I would build the model using this one, find out what's the prediction accuracies, three of them. That's what people do typically actually. And ReLU has been consistently doing better for me in all the data sets that I tried. So
Wonderful. Yeah. So he has also added, he wants to add on, he said that an interesting question that could be discussed at the fag end, how will all this change when quantum computing comes into effect? So very briefly, if you can throw a little bit of light into that.
Yeah. I work with a lot of quantum computing. I am a venture capitalist, right? So we are working with a couple of quantum computing startups right now. When they're
Right,
deciding whether to invest and all. So as part of that effort, I need to understand, learn about their technology and all. Basically, what happen is like the computational power is gonna go exponentially, right, in the next 5-10 years with quantum
correct,
computing. Then
correct,
right now one of the big bottleneck right now is like if you have like 100 hidden layer uh, deep learning model, only the Googles can actually have the computational resources to train it, build the model, right? So but if you have that much more computational power, you first of all you can build much more complex deep learning model instead of like 100 hidden layers. Why not 2000 hidden layers? Because you know the only constraining factor right now is to estimate those weights is going to take that much longer, right? So if you have that much more computational power, that's when we are talking about like the Terminator guy kind of situations, the
yeah,
sci-fi robot kind of people, doing things better than human beings can. That's the
absolutely
future we are looking at.
true. True. So next is like Abhishek actually wants to, he has mentioned he wants to know a little bit more about gradient descent. Gradient
Yeah.
descent, I mean, can we throw up lights in like maybe a minute or two? Because I mean, we are always already 12:30, so maybe we'll have it for another 10-15 minutes extension since people want to interact.
Yeah.
But quickly, if you
Yeah,
can
yeah.
like,
That's a great gradient descent. So, we talk about in that paper that we wrote, we used a batch gradient descent. So it's an optimization method. It has been there for centuries. Back propagation uses that method. Basically, it's saying like, iteratively recalculating the weights based on their gradient. Okay, so
right,
there are and gradient descent in the traditional sense, it's like using that full gradient matrix, which would be impossible in our case. It will be because there are like a million weights to estimate, so it will be like a million by million matrix. All the computers are gonna blow up with that. So people have been doing a couple of things with that. So one thing that people use is like a batch gradient descent. So what that
right,
do, that's what we do in the paper also. So instead of using the entire data to calculate that gradient matrix, we kind of randomly get a subset of the data, which is not as perfect as the using the entire data, but nevertheless this doable with the computer, because that's a situation that comes up all the time, because we are pushing like the limits of computational power more often than not. Like the data sets are so big, the calculations are so high. So one way people have been able to fit complex deep learning models is using something called batched gradient descent. So basically, instead of using the entire million data points uh, to calculate all the weights, what they would do is like, okay, let's fit the model using the first 15,000 point. Okay, then you get
right,
one estimate. Then keep on, randomly doing that. Eventually, you go through the entire big data, and then that's what we also did in the paper. So to answer this question, there's a gradient descent is like a it's like a optimization method using the gradient of the variables, and in back propagation, that's what they do actually. And if for certain loss function, not all of them, if it's like squared loss function, that gradient matrix reduces considerably in backpropagation algorithm. But it's a huge amount of stuff to talk about. I mean, I don't even imagine I can explain to you in like the next 2 minutes. It's like,
No, no, of
too
course
much
not.
stuff going on.
Yeah,
Yeah.
as I said, like just like a couple of minutes of throwdown. So yeah, I mean lay down rather. So
Yeah.
yeah, of course, if we have to discuss anything, these are all topics where we can discuss for hours.
Yeah, yeah,
So
absolutely. These are vast topic. Even the smallest one, people are written like 200 papers about it. So it's like,
so quickly going to the next question. It's from Rajul, and Rajul says, "Sir, I have two questions. First, how to architecture the model. Secondly, when it comes to finance, to ensure data security, there is a surge of data. So how can we get a data set that trains the model in the right way? Is there a, I mean, he has mentioned as a star dearth of data set. So this is his question in total.
okay. All good points. The first question, let me remember. So you was asking about the, um, uh,
How to
yeah,
architecture the model?
absolutely great question. Actually, fantastic question, because these are like practical aspects of actually building the model, right? And couple of points I would like to raise is, more the hidden layer, the better the whole thing is going to be, right? More nodes and higher number of uh, uh, nodes and connections in the deep learning network, that's better. But what happens is, like, the computer freezes very, very, very soon. Even if you go
That's correct.
beyond, like, uh, for the paper that we, even if we go beyond three hidden layers, you are like looking at very, very slow computation. For our purpose, we had to use, like, cloud computing, Amazon AWS infrastructure to do everything in a timely fashion. So only constraining factor uh, is the number of hidden is a computational resources you have. And but
Correct.
the second point is, like, having said that, this is a I'm thinking about, writing a paper about that. There are like certain number of nodes that has produced, like, surprisingly produced, there is no produce very, very accurate models. For example, multiples of, exponents of 2, like, if you use like 516, or there is no 10 24 nodes on it. There gotta be some reason behind it, which I am trying to figure out myself.
Right.
But so that there are some, and people have figured that out in the past papers also. There's no explanation to it. There gotta be some reason behind it. That's, Mr. This guy has to figure it out. But but there are certain, especially the multiples of if you have 256 nodes, 512 nodes, 1024 nodes on every hidden layer, for some reason the accuracies are much better than, if you just say 200 nodes, so things like that. So, but why that's the case, no answer. People are still doing research on that.
True. True.
Yeah.
True. Right. So coming to the next question, Sachin has asked, what is the criteria for admission? So yeah, that's a question for me. But as I said, regarding the course and all, we will discuss that separately. But since you asked, just like for a quick reference, criteria for admission for all our courses are like, we generally have like a small discussion or interview, whatever you want to call it. First, we want to ensure that like the course that you are trying to enter is the right course for you. So we generally have a discussion before any participant takes admission in any of our courses. Each course has its own prerequisites and all that. So depending on your background and depending on your interest, then we'll have a discussion, and then after that, based on your profile, we will be suggesting a course which is right for you, and not only profile, but I mean profile and interest. We'll suggest a course which is right for you. So if you get interested in any of the courses, do directly get in touch with us through phone or email. All that is mentioned in the website. And at the end of the session, again, I'll put up with the contact details once more. But you can always go to our website iiqf.org, and then you can select the right course which is of your interest, and you can make an inquiry, or you can directly call us from there, email us from there. In any case, since you have mentioned, I'll ask one of our guys to actually get in touch with you and discuss about the courses. The next question is from Lian. So he says, hi Sujit, thank you for your sharing. Could you please give us an example about the machine learning used in banks to reduce credit risk of individual loans or credit cards? As machine learning method is hard to explain the impact of each variable, what's the regulatory view about using machine learning method to make credit risk decisions of individual loans or credit card in banks in America? Many thanks. So that's his question.
Yeah, absolutely. That's a that's a problem of using machine learning in assessing credit risk. Certain scenarios, but even in the US, not all states have such laws. Certain states have laws. Okay, if you reject a credit card application, you gotta explain to the guy, why you rejected it. But other states that don't have that law, we can still use the machine learning models. And credit risk is, it's not just individuals, right? So if banks are giving loans to businesses, for example, or
Right,
and those are probably bigger part of their whole operation than individual credit cards and all. So those
correct,
kind of things, you can look at the macroeconomic data, for example.
right,
What's the prospect of this particular company succeeding in the next 5 years, that sort of
correct,
things. And we do that in our investment decisions too. I mean, we are doing similar stuff in our VC firm, kind of use all sorts
right,
of data, like we use social data, economic data, and everything to kind of assess and in industry data, and the founders profile data, who are these guys who are leading the organization, right? So all
correct,
these things you can throw it into a deep learning model, and model can tell you, like, it's always never going to be like 100% accurate, but it's better than
right,
nothing, right? So it's like so if we can say something with 80% certainty, that's like better than kind of following your gut instinct, right? So it's like
absolutely,
so
absolutely,
so I believe, so there are whole bunch of ways we can do. And regulatory aspect, beyond the credit thing, they are trying to develop some framework for AI stuff and all. There is like a laws that are being discussed right now, because they which are, I don't know, I mean, a little bit, people are a little bit over concerned about AI, taking over things like that. But there is an ethical aspect for sure, because I was reading a paper recently written by a Stanford professor, and
okay,
for example, AI can, just looking at somebody's picture, photo, AI can predict face recognition, right? AI can predict like a whole bunch of stuff about that person, which is kind of creepy and unethical probably. But so that kind of situation, there are going to be laws coming up, and uh, you know uh, you so those are regulatory aspects that might be on the horizon, uh, uh, regarding using AI for individual credit decisions and all.
right, right, absolutely. Right. So now going to the next question is from Krisha, and she says that as someone very new to this field, how can one start reading and understanding about ML, including the related statistical equations?
Okay.
Uh,
Oh, great question. I Okay, so before you can apply ML in finance, FinTech, you gotta get grip on ML itself, right? Then you can think about using ML in FinTech. There is a great book that I recommend. Let me look at the. Okay, so let me look it up here. So I can tell it to Nitish. Deep learning people use like something called TensorFlow. That's what I use also,
Correct.
and Python. So I'm looking up that book name. That's the book. That's the book I recommend. Yeah. If you want, I can tell Nitish about it, and then I recommended that book to many people. Actually, that's a good starting
Sure.
point. To get a good grasp on building actual hands-on Python. That's the name of the book itself. Hands-on Python machine learning using Python or something. Now I'll let Nitish know about it. Then you can.
Sure. You can pass on to me, and I can share with them.
Yep.
Wonderful. Sure. Going to the next question, it's from Prasant, and Prasant says that he's a data scientist, and he asks, "Can I shift to quant researcher?"
Can I what to?
So he says, "I am a data scientist. Can I
Yeah.
shift to quant
Oh,
researcher?" So what he means
oh,
is like, can I
yeah,
shift to quant research?
absolutely.
Basically,
I think okay, quant researcher is like it's a whole bunch of stuff, right? So if you in quant researcher, they want some guys might be working on valuation, that sort of thing, or okay, I don't know much about what exactly a quant researcher does. You might be able to tell that better, but but certain areas of quant research definitely it's a big overlap with a data scientist, profile.
yes, absolutely, and absolutely. And Prashant, to add to what Sujit has said, see, machine learning as it is. I mean, it's like, as you all know, right? So it's like machine learning and AI and all this is like a field which is applied to all kinds of industries. And our industry of quantitative finance or finance engineering, whatever you call it, is of course not immune to it, right? So a lot of work is happening in our industry where they use lot of machine learning models, and lot of work is happening in this field. So if somebody has a data science background and has an interest to move into this part of finance, that's a very good combination. Of course, you should learn the domain of finance engineering before moving into this field, and that can be combined very well to target a lot of profiles. Yeah, I mean, not to advocate our courses, but yeah, I mean, one good way can be, a start can be to learn the domain from any of these courses and then combine that with your background to make an entry. We can discuss that in length separately. You can get in touch with us. But yeah, it's definitely not only possible, it's like a very good combination, data science along with I mean, somebody wanting to move into quant research, a very good background to have, being a data scientist. uh, Going to the next question, Rahul says, average package after this course completion. Okay, very briefly again, as I said, regarding courses, we'll discuss, take it offhand. Will not waste much time of the session. But since you have asked, very briefly, see, I mean, ours are professional skill enhancement courses, right? And most people are like working professionals, and they already some of them are like, I mean, on an average people have like I mean, 5 to 8 years experience. There are people having more than 10 years experience. Of course there are freshers as well. So people come from different kinds of background, that is what I mean to say. And then, I mean, it is not about only one single course. As I said, we have around 4 or 5 courses, so it depends on which course you are talking about. But yes, if you are doing any of this the broader comprehensive courses, safely it can be said that on an average you can expect like a 30 to 60% hike on the current CTC that you are drawing. If you have some relevant background. If you're not having a relevant background, then the hike may be lesser. Again, this is something it's like not one I mean, the one answer that fits all. People come from different kinds of backgrounds, so we'll have to know more about you, Rahul, before commenting on that in detail. So would be happy to discuss and guide you regarding, I mean, what kind of jobs and what would be the package that you can expect. But I mean, it's very difficult to generalize because people will come from different kinds of background to us. I mean, their profiles is not homogeneous since these are professional courses, right? So Rahul, I mean, yeah, I mean, you can always get in touch with us directly over call or email, and we'll be happy to guide in detail. Next question is from Nikhil, which happens to be the last question for the day.
Yep.
So he says, how do we see this new program, FDP, Financial Data Professional, which is purely finance-oriented machine learning by CAIA, which is like the Chartered Institute of Alternative Investments, effective in this field? I mean, is this industry accepting FDP is big time yet? So do you have some idea about finance data professional?
Oh, you're asking me?
Yeah, I mean, the question is for you, but like, it,
I mean,
it,
I thought it was like a more the IIQF type of question. I don't know anything about that CIA and all. I'm US based.
yeah,
I know a little bit, but
very honestly speaking, again, have heard about this course, but I mean, have not gone through the details yet to comment on this particular program, Nikhil, very honestly speaking. Uh, but data professionals, I mean, if the course is good, it should be effective. And coming from a body like CAIA, I'm sure they have made a good course out of it. Okay, but more than that, it will be difficult for me also to comment because I have not gone through the course structure or details in that detail to actually comment. Very honestly speaking, we'll have to go through that detail. I mean, maybe if you want me to do a little evaluation, I'll be happy to go through that detail maybe over the next 2-3 days, and then again you can connect with me separately on that, and I can guide you. But at this point of time, I would reserve my comments on that because I do not have detailed idea, though I've heard about the course. Right. So with that, we are coming to the close of the session. I don't see any more questions. Let me just quickly recheck. Okay, now there are a couple of questions. One question we'll take, and then of course it's already we are 20 minutes past the session, but like good. I mean, if we are having interaction, people are interested, so it's like for them. So
yeah,
I mean, I hope like you also would have like
no,
maybe 5 more minutes. So
yeah.
Sachin was asking the criteria for admission in masters. Sachin, any graduate can apply. There is an admission criteria in terms of languages and all that. Do get in touch with me, and we will discuss that in detail. And then, if you wish to apply, I mean, we will pass on your application to the university for to take the admission forward, right? So do get in touch with me separately on this, and I'll be happy to guide you. Jacob has a question, and he says that how can artificial intelligence and machine learning help with reducing persistency risk in life insurance? Would you have some idea about that question?
Well, uh, life insurance. I mean, actuarial models, they always use like a statistical data science models, right? So with this AI ML models, you can always kind of make it more accurate, more effective, more more what can I say? It's like a more efficient, more everything can be made better with deep learning model if you have sufficient data. And I'm sure the insurance people have like a huge amount of data to work with. So yeah, definitely I can see that already being applied. I know that these auto insurance people, they are using AI ML extensively in the US. To come up with a more accurate premium amounts and risk profiles. So definitely same thing can be applied in the life insurance situation also, I would think.
Sure. Right. Right. So yeah, I mean, thanks so much for that explanation. So I think there is no more question. Thank you so much for your patience, Sujit, in answering all the questions elaborately. I must say, I mean, I appreciate your time very much, and I would
Okay.
really like to thank you once again for joining us and sharing all your valuable insights. Coming from you, it's like means a lot. And like again, I'm sure all the participants also definitely would have benefited from like such deep insights, right?
Yeah.
So with that, like I mean, thank you once again so much. Have a great weekend, and we will connect with you again.
Uh, Absolutely. Thanks to this. Thanks for give me this opportunity to talk to these guys. So hopefully I can interested bunch of people in machine learning. That would be fantastic. And so I got high hopes for ML becoming a pretty already is, but
Yeah,
you know
yeah, it's already is, and I'm sure it will go deeper. I mean, more and
absolutely.
more people actually. This is like something where which everybody should have some idea. To be honest, I mean, whether this applicable
Absolutely.
or not.
I totally agree with you. I agree with you.
Yeah, so it's slowly becoming all pervasive actually. I mean, in all industry. So yeah, this is something which is like very true. I mean, everybody should have some idea about like things related to machine learning, AI, and all that. With that
Yep.
note. Thanking all of the participants also for taking their time out on a Saturday and joining us. Hope you all had a great time. Hope you all have enjoyed the session and like liked our insights. Thank you once again, Sujit. And with that, we'll close the session for the day. If anybody has any question regarding the courses or anything, maybe even after Sujit leaves, I'll wait for like 1 or 2 minutes, and if somebody wants to ask any question related to the course, I can take it offhand after Sujit leaves, right? So I'll be waiting for you. And in the meantime, as you can all see, I mean, these are the contact details of our institute. So you can go to our website iiqf.org. You can contact us on the phone number 976986051, or you can email us to info@iiqf.org. So with that, we'll end the session. And as I said, I'll be waiting for a couple of minutes to take questions regarding the course in case anybody has those. But we'll stop the session formally. And thank you, Sujit.
Okay. Thanks. Talk later.
Yep, sure.
All
Take
right.
care.
Okay.